Okay, guys, this should be recording. So, yeah. Okay, looks like it is. Cool. Alrighty. So, better late than never, but it is here. So, on this example, there is a triangular prism, and we have to find the surface area. So, we need to find the area of every piece and add them together. As KC brought up, it definitely is an equilateral triangle, and that can be split into a right triangle to help us find that area. And some of you guys expressed interest in how we would do that, so I'm definitely going to show you. So this is our triangle. Every side is 6 meters, and it is equilateral, so that means every angle is 60 degrees. Now, if I want to split this, and I'm actually going to draw it bigger because I'm going to do stuff to it. So here's our triangle. And then I'm going to split it. So it was 60 degrees and 60 degrees. And then as I split it, I'm dropping a perpendicular bisector. So it bisects it at a 90-degree angle. So I created 2 right triangles because what I really want to find is I want to find this height because I need that for the area. So since I split it right in half, instead of the whole thing being 60, this is 30. And I know that if the whole thing is 6 on the bottom, that means each side is 3. And special right triangles have a special relationship. This is a special right triangle because it is a 30, 60, 90 triangle. And when you have that, and I'm actually just wanting to make sure I have the formula right. There it is. When you have that, it creates a special sort of pattern. So no matter what the sides are, they will always break down into the same ratio. So you'll have your triangle, you'll have 60, and you'll have 30. So whatever the 30 side is, whatever it is, the 60 side, the side opposite the 60, ends up being whatever's on the 30 side times the square root of 3. And this is a pattern that mathematicians have found long ago. And then whatever the hypotenuse is ends up being 2 times the side opposite the 30. So what we're trying to find is we're trying to find the side opposite the 60, or the height. And we know that the side opposite the 30 is 3. So that means my height would be 3 times the square root of 3. And that's it, really. And then if I needed to find the slant height, I would go 2 times 3, but I already know that it's 6 because it's an equilateral triangle. So yeah, my cat just tried to climb my pants. So I'm wondering if she wants to sit on my lap. Come here, baby. Come here. Yeah, oh, she does. She's a snuggle baby. There she is. See? Say hello. Okay. So now, apparently she's been using my lap to jump on my other cat, so we'll see how this goes. So now I know what the height is, so I can very easily find this surface area. So I'm going to find the area of the 2 triangular bases. And to do that, the formula is base times height divided by 2. So my base is 6. My height is 3 square root of 3. And I would divide by 2. And I'm going to simplify it a little bit for now. I'm going to go 6 times 3 is 18. And I'm going to kind of leave that square root of 3 there because I don't want to multiply by it yet. Because when I do that, my answer gets really inaccurate. And then 18 divided by 2 is 9. So I get 9 square root of 3 for the area for one of the triangular bases. So this is 9 square root of 3, and this is 9 square root of 3. Now I need to find the area of all 3 sides of my prism. So to do that, I would take the 12 times the 6. And 6 times 12, Jen is tired, so she's going to use a calculator, is 72. So this would be 72. It would actually be 72 all the way around because you have 12 as your long side and 6. So 3 72s and 2 9 square roots of 3. Now I'm going to add them all together. I'm going to go 72 times 3 because there's 3 of them, plus 9 square root of 3 times 2, essentially, because there's 2 of them. So 72 times 3 is 216. 9 times 2 is 18. 18 square root of 3. Now I'm going to actually add it in my calculator. 18 square root of 3. Once I add it all together, I get 247.2, we would say, and we would call it meters squared. And that would be my area. So that is how you do it with a special right triangle. Now for a cylinder we use this formula. We take 2 pi r, so essentially a circumference formula times the height plus 2 pi r squared. So it's the area formula times 2. So 2 areas and then 2 circumferences, basically. Well, 1 circumference times the height. Okay, so I want to find the area of this, the surface area of this cylinder. First thing is I need a radius, not a diameter, so it's going to be 8. So I'm just going to follow the formula. 2 times pi times 8 times 21 plus 2 times pi times 8 squared, which is 64. And I'm going to kind of simplify things down a little bit. I like to leave pi there until the end. So I'm going to multiply 2, 8, and 21. We get 336 pi plus 2 times 64 is 128 pi. And then since they both have pi next to them as a variable, I can add those together. That way, if they wanted my answer in terms of pi, I would be able to give it to them. This is considered an exact answer. If they wanted a rounded answer, you would multiply by pi. And you would say 1457.7. So this is exact, and this is an estimate or a rounded answer. But to do the surface area of a cylinder, you're just following the formula. Now to do volume. I love doing volume because volume, it's pretty easy. It's not bad. For a rectangular prism, you're literally going to just take all 3 numbers and multiply them together. Does not matter what order. For the volume of a prism, it kind of ends up being similar. You multiply all 3 numbers and just cut it in half, divide by 2. Volume of a cylinder, you do have to do the area of the base times the height. That's the traditional formula, area of the base times the height. So for the volume of this guy here, I want to find the area of the base. Now, what is the base? This is obviously has a triangular shape, so it can't be a regular prism. And then I notice that there are 2 of them. So my base is definitely going to be these triangles here. So the area of my base, we use as big B, actually. We call it the area of the base. We're going to go base, which is 12, times 16, divided by 2. So 12 times 16 divided by 2. 96. So my area of my base is 96. Now, if I want to find the volume, I'm going to take that 96 and multiply by the height, the thing that makes it 3D, and that's this 10. That's what extends it out. That 20 is still part of the base. So I'm going to multiply it by 10. 96 times 10 is 960. And this one we're going to label as centimeters cubed. So there's that. Beautiful. All right. The next part. Oh, I also want to show you how if you don't like thinking of the area of the base and whatever, here's another thing we can do. We don't need that 20. That's just a slant height. We don't need it. 16 is the height of my base. 12 is the base. 10 is the 3D height. It's what makes it 3D. If we multiply all of those numbers together and then divide by 2, you will get the same answer that we just got. 960. So you just gotta be careful to ignore things that you don't need. Okay, you need a height, a straight up and down height, a base, and one of the three-dimensional measurements, whatever makes it 3D. Okay, to find the volume of, this one. This is the volume of a prism. We want to find the missing measurement. So this one, again, you just multiply all three of those numbers together, and we're missing one. We don't even need to label it. We can just say 6 times 5 times whatever we're missing, and it's supposed to equal 510. Well, this is just a straight one-step equation. 6 times 5 is 30. I want to solve for x there. That gives me a value of 17. So my missing measurement is 17 inches. Definitely going to be this one here. So just follow the formula, guys. Okay, now volume of a cylinder, I'm going to find the area of the base and multiply by the height. So the area of my base here, my base is definitely the circle, so I'm going to go 4.9. That's radius squared times pi. So 4.9 squared. And you're already going to get a decimal here, so it's fine if you multiply by pi times pi. And you get like 75.42, blah, 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 blah. Then we have to multiply. So that's the area of the base. Now we're going to multiply that by the height. And I actually just leave it in my calculator, and then I just hit times 7.8. It's more accurate. And you get 588.35 feet cubed. Unless it tells you, I would round to 2 decimal places. It's more accurate. All right, the last thing, find the radius of a cylinder with a volume of that and a height of that. So we want to find the radius. So the formula for volume is pi r squared times height. So because that's the area of the base times the height. So the volume they gave me was 622.04. I know pi, I don't know radius, but I know the height is 22. So 22 and pi are the things that I need to get rid of. So since they're both being multiplied by this radius squared, I'm going to divide by the 22 pi. And you can totally leave it kind of together because 22 times pi is just telling you to multiply that number. So we're left with radius squared. And I'm going to go 622.04 divided by 22 pi. And I always put parentheses around the 22 pi just to make sure that doesn't mess anything up. And we get 9.0000 whatever. And then we're going to take the square root of that, and you get about 3. So you get a radius of 3. Because the square root is how you cancel that squared. I highly recommend having a calculator like this one because you can store answers in there, and it helps. So that's it. That's all I have for you, lovely people. That was the rest of our lesson. I really hope that next week it's less distracting for everybody's sake, because come on, nobody needs that. And guys, you're the best class. Have a good night. Let me know if you need any help.